Let's make a simple technical presentation of our character here in Unreal. I've already imported all the geometries and created the materials with the relevant textures. So I won't show that part, because this isn't a character course. Once everything is organized, you'll be able to follow along with me. These are my settings in project settings for exposure, lumen, and ray tracing. I'm using ray traced shadows. And that's it for the project settings. I've divided this character into 3 pieces to show what I like to do when there are multiple geometries composing the same character. I'll start by creating a new blueprint. Choose Actor. Double-click to open the blueprint editor. And don't worry, we won't do anything complicated here. You'll drag each of these geometries into the hierarchy list. I've brought in the body, the head, and a special geometry for his eyes. It's okay if things are out of place, as in my example. I left it a bit messy on purpose so you can see how simple it is to handle it. I'll select the eye geometry and his head and try to position them manually and carefully. I already misclicked, but let's continue. Navigation in Unreal is always tricky, either too fast or too slow. Once everything is in place, compile and save. The materials have already been applied in the blueprint because before starting this, I double-clicked each of these geometries. Here in Unreal, it's called a static mesh because they don't have any skeleton or rigging. Inside the material slots, I've already configured each of the materials. So, anywhere I add this geometry, it will appear with the materials. Now, I no longer use the character's geometry but the blueprint. I place it in the scene, set it to 0 in space, and here it is. I'm still viewing in unlit mode because there's no light. If I switch to lit mode, everything goes dark. I also created this plane in Blender. I'll place it in position, but it's not the correct size. I don't know which side is rotated correctly or incorrectly, but it doesn't matter to us. I'll rotate the character, increase the size of this plane a bit, and apply the corresponding material. As you can see, this material is super simple, just a color with 89% white. We still don't have any lighting, but as we've done in other projects, just because it's a character or Unreal doesn't mean it's different. I want to add an HDRI to provide a soft ambient light. If you haven't activated the HDRI backdrop plugin, do so. Otherwise, it won't appear in that list. This weird effect is just things intersecting precisely at 0. To fix this, I can lower the HDR backdrop or raise everything else. Now, it's illuminated by this ambient light with the standard HDRI. I've also brought an HDRI that I prefer over this one. It's simpler and the ground isn't green, it has a dirty brown ground, so it affects ambient lighting much less. Note that the name says texture cube and not texture. That's because it's an HDR file, and it already has the coordinates that will allow the HDRI backdrop plugin to function correctly. Select the HDR backdrop, turn off the option I enabled earlier, and change the texture. Much better this way. I'll also reduce the intensity to probably about 20%, maybe even less later. But now the effect we're experiencing is this annoying exposure control. Although I know I want to use a camera for rendering, I don't want to work through the camera. So I'll go back to project settings, and in the exposure options, I'll just turn off auto exposure. Now the intensity responds to the number I set, making it much more predictable, and I can adjust it later through the camera or a post-process volume. I can now add an area light and reposition it somewhere. What we're aiming for is a neutral presentation that showcases the character well. This doesn't mean we don't need the photographic contrast curve. It's something that should always happen. What changes is the image style. I don't want any part hidden in shadows. Normally, we won't want to use very colorful lights or camera effects. It's more neutral in the end, which is best for presenting your model. After all, it doesn't make sense for a magical soldier like this to be in a studio setup. So clearly, this character is already in an environment where it doesn't belong, and we have to make the most of it. The minimum I can do to extract the shapes in an interesting way, creating a gradient in the forms, is using overhead lighting. If I use frontal lighting, there will be fewer shadows on the shapes relative to the camera, resulting in less definition of each form. To summarize, we're aiming for neutral lighting that effectively represents our character shapes, which is typically from above. I'm happy with this start. Now, I'll add the camera and begin evaluating the final image through it. With the camera, I can apply lens effects, make color corrections, and work based on the final result rather than something abstract. I want the closest result in front of me as I work, which is why we should add the camera soon. It will change the image's appearance. Place the sign camera actor, view through it, and reposition it. This layout will be used for the final render, with 3 angles of the character, not one at a time to assemble later in Photoshop. I'll take this blueprint, use the Move tool with Alt pressed, rotate it 45 degrees, make another copy, and show his back. I've worked hard on this cape, so it needs to be shown. Press Ctrl-Shift-S to save general changes in all Unreal elements. This camera comes with focus enabled and some lens options. Most of the time the settings are already good. The aspect ratio is probably Full HD, or rather, the sensor is Full HD in its aspect ratio. To avoid having a blurry screen in front of me, I'll first adjust the focus options. Manual focus, distance 100,000 centimeters. As always, I like to set the minimum. I just type 1 and press enter. The minimum is 1.5, and then I gradually increase it. If the scale of your scene is too large or too small, this number might be far from or close to 1. So, I can't use the eyedropper option from favorites. I have to scroll down or type focus in the search box and manually click the icon and then the object. Now the focus is set and it's about 600 centimeters from the camera. To give this character a more grandiose appearance, you can see the camera height is around his waist. If I move it too high or too low, this effect might change. Now, I'll experiment with you to see how it looks if I raise the camera. I will rotate it a bit. The framing is similar, his entire body is visible. All 3 angles are visible and the lighting is the same. But still, I don't feel the same, I prefer the other one. If you prefer this one, please don't let me influence you. Think for yourself. I'm just trying to show how I feel with each different angle. It's extremely difficult to explain, and I don't think we can be objective in any of these explanations. The best answer is I feel this way, and this is how I like it, and this is how it will be. And that's a perfect response to this problem. The project is already in manual exposure mode, but I want to set my camera to manual mode too, just to be sure of the method I'm working with. When I exit it and return to the normal viewport, the lighting will be similar, or at least not too bright or too dark. We already know the hierarchy between the scene, post-process volume, and the cameras, so there's nothing mysterious here. Look, when I set it to manual through the camera, the entire scene went black. It's been my decision from the start, but I'm describing my thinking for you. It forces me to work with real light values. I want to work as physically accurately as possible and then artistically tweak those values. A softbox, which is what this rectangular light essentially represents, can have super varied lumen values, because it depends on the size of the softbox and the bulb inside it. The softbox is just a material that diffuses the light, and the light inside can be almost any type. But an interesting starting value for us is around 5000 lumens. So let's change the unit to lumens and set it to 5000. Now our camera, which is physically correct with the shutter speed, ISO, and aperture values, is reacting realistically to this softbox with around 5000 lumens. In a real photo studio, I would just go to the lamp, which has an intensity button, and increase its intensity in lumens. But see, I'm not setting these 5000 values randomly. I didn't reach them by dragging this slider until I got here. In fact, I'm not even sure if it allows reaching here. Look, it only goes up to 2000. So, to avoid doing things randomly, we've been learning all this craziness up to now. A lot of technical parts just to finally type one number. 5000 is obviously not enough. But what would happen if I increase the area of this softbox? Instead of 64, I'll set it to around double, 120 in each dimension. And look how interesting. In the real world, if you don't change the light's power but change the softbox size, what changes is not the intensity of the light, but how it is distributed in space. And this alters our perception. In Unreal, even if I set a softbox to an extremely exaggerated size, like 1 unit, the intensity doesn't change, only the shadow quality. This doesn't represent the real world. We should also perceive light differently. Unreal compensates for the energy distributed over the softbox area. In practice, this saves us from having to make multiple adjustments. If it were truly realistic, altering the light area size would also require changing the intensity. Each program handles this differently. Usually you have to toggle an option called normalize. Unreal doesn't work this way by default, but I thought it was interesting to mention. I'll go back to 120 to see how the shadow looks. Very diffuse, and compare it again with 60. Honestly, I prefer diffuse light, so I'll set it to around 100 this time. The intensity isn't enough. If we were in a photography studio, what could I do? Change the camera exposure, add more lights, or increase the intensity of just this light. There are various options. First, I want to see the size of this light in relation to the character. The reality is that this light can be much larger. If you've ever been to a photography studio, you'll find gigantic softboxes. Since I want to light with just 1 or 2 lights, I'll double this softbox size. And I'll also compensate the lighting. Before we overdo the intensity of this light, let's turn it off and recalibrate our ambient light intensity. If you remember, the original intensity was off camera. Now that we're using a camera with physical properties, we need to adjust it too. We can hide the light or find an option called Affects World. Basically, you turn off the light. I prefer to just turn it off in the outliner. Select the HDRI backdrop and increase the intensity. Maybe 1.5 or 15. We don't need to use the exposure tool, which is a more artistic and intuitive process. Now it's a bit better. A light to outline the silhouette is always interesting. Let's try duplicating this light, positioning it behind the subject, but at an angle from the left of the camera. Perhaps even change the color of this light a bit. Then do the same on the other side. Clicking that icon in the top left corner, we switch from global to local navigation for these transformation gizmos, especially for the light and camera, which is very important. Unreal's viewport navigation isn't great as it is, so we try to make the process a bit less cumbersome. Now I've added a lot of light to the top of the character, but it's overly bright now because his head is all white. I'll try to compensate by moving this front light a bit forward and adjusting the angle and reducing the intensity. Keep adjust, keep trying. I wanted a more defined light from one of these angles without creating harsh shadows. But now that we've added more lights, the shadows naturally fade because there's more light filling them. So, for this main front light, I'll reduce its size and see if I can bring back those more defined shadows. Since we're here, let's see how it looks if I add a slight blue tint to these side lights. Obviously, we can do this with color temperature or directly in RGB. I like the effect of this subtle blue hue. So, I'll revert to the standard and use the temperature, allowing me to use the temperature on the main light as well and inversely add a warm light. Now, adjust the temperature on all of them and let's review them one by one. Pressing the G key will hide all the gizmos or elements that are not the scene's geometry, giving you a preview that's much closer to the final output with a cleaner screen. With things more or less in place, let's adjust the camera options, focusing on lens effects and some light color correction. To start, we'll look at the bloom effect, and also add chromatic aberration. Let's go to film and check the post-processing and film back options. This ratio is Full HD as we saw 16:9, but I want to switch to DSLR. The resolution remains the same, but the default lens options are slightly different. Before adjusting post-processing options, let's fix the distance and the focal length. A 35mm lens causes a lot of distortion, especially for a tall character in a full-body shot. Now I'll start with a much longer lens like 18mm. Of course, the distance changes, and we'd have to step back in real life. If the focus shifts, just click the eyedropper and select your character. Now we can go back to film, and in post-processing, I want to enable slope, shoulder, and toe. Let's start with slope. Adjusting contrast, the default is 1.88, not 1.9. For shoulder, more or less contrast, set it around 0.75. Toe is the image base, adjust for less or more contrast. I don't want film grain in my final renders, so I'll set it to 0. If I want to brighten or dim the scene later, I could tweak the lights, but I'm tired of walking to the light switch in my studio. I prefer staying behind the camera and adjusting its options. The easiest way is with exposure compensation. I can increase one stop by setting it to 1, 2 stops by setting it to 2, brightening the whole scene. Thanks to 3D magic, we don't add noise to the image. Finally, for color corrections, we still use the camera, no need for a post-process. To make navigation easier in Unreal, which is terrible, let's try using color grading. It automatically selects the camera for us, so save first and let's go. At the top, it filters for us between global changes or just the darker pixels. Medium pixels and lighter pixels. I think I can adjust everything by changing the global channel and maybe in the shadows too. Let's go. I usually like to give metals a different reflection color. Even if it's not physically correct, I really like when metals have a slightly greenish or bluish reflection. So, to avoid it looking like I'm changing the temperature, I'll change what I said before. Actually, I'll separate by channels just to try to select those very bright metal reflections. Let's go to the highlights then and try the gain. A bit more towards the cool colors. I'll go back to the shadows or midtones and compensate with the inverse color. I'll try the midtones first. That was too strong, so I'll go back and try the shadows. I can see most of these changes under his arm, which is expected. It's the darkest part of the scene. I'll try to reduce a bit here and see if you can notice. If I make it really red, I think you'll be able to see it. I prefer these local changes over something generalized like a temperature change for the whole scene. And globally, what can we do? Maybe adjust the overall saturation. Let's experiment. I think it deserves a bit more saturation, especially with this cape I chose to keep a strong orange. And look at the difference it makes, just 10% to 20% more. 10% is too little, 20% is too much. So I'll set the saturation to 14%. What if I change the scale of this plane to infinity? I want to see the shadow effect in the background. Let's try it directly here. In the outliner properties, I'll set it around 1.8 or 2. Let's go with 1.8. Since I'm here, I'll change the lights to movable. It doesn't make a difference in this setup, but it avoids future rendering errors. Lumen already ignores these functions, so it was calculating lights in movable mode. But to be technically consistent, let's set it correctly. I'll move the camera back a bit to give it some breathing room. Check the focus once more, and I think we can reduce lumen. A small setback now, right? You noticed it's a back and forth process, and that's normal. I worked a bit more on this scene and want to show you the small changes I made, which resulted in a slightly different image than what you've seen so far. First, I want to show an option that can be activated on any object in the outliner, but I use it especially for the camera. To see it in the menu, I'll move the outliner to the side. This option is activated by right-clicking, going to Transform, and enabling Lock Actor Movement. This is particularly useful for the camera to prevent moving it after we've chosen its composition. I often misclick with the left button and end up moving the camera slightly, which annoys me and wastes time. The same result could be achieved by creating a new level sequence, adding the camera and keyframing it. But I find it quicker to just right-click here. With that out of the way, let's turn the lighting back on, return to perspective, and I also added a post-process volume. This allows me to work with more natural lighting outside the camera view. You've probably noticed that when working with physically correct values, the lights are much stronger than the default. Without this post-process, look at how I'd have to work. One option is to set the viewport to unlit, but sometimes I want the lighting on without it being too strong. So once again, we will consider the hierarchy between the PPV, the camera and the project settings in order to make smart choices. That's why I've added a PPV, turned its infinite extent option on, and under exposure compensation, I found a value to visually tone things down a bit. In my scene with this lighting, I set it to -6. And that's enough for me to see things clearly. Another thing I did was go back to Blender and remodel the background. This way, it's a bit easier to get a smooth transition between the floor and the wall. Finally, I spent some time adjusting the position of the lights, their temperature, intensity, and size. In the end, I decided to use just 2 lights. The main one is still in front of the camera, but slightly more to the right of the composition. The backlight, still with a bluish tint, is more from above, as you can see. It's not directly behind the character. Instead of just changing its size, we can use scale, which works a bit differently for light in real life. Scale affects the area of influence of the light. With a small scale, the lighting doesn't spread much. It reaches the character, and as I increase it, it reaches his head, the middle of the cape, and finally the floor. If I leave it at the default value, it will illuminate everything. My thought here was that I didn't want this light to wash the entire scene with blue. That's all. I also tweaked the color grading with the camera selected, and you can see my options here: global, shadows, midtones, and highlights. I compensated the exposure using the camera's manual settings. I think the only thing I changed was the ISO. It defaults to 100 and now it's at 300. Looking at this image, I think I'll increase it a bit more. Now it's at 400. The background material was around 80% and now it's almost at 70%, so it's a bit darker. With everything under control, I'll set the viewport to unlit to save some electricity and stop my computer from sounding like it's about to take off. In Content Browser, I've already created a folder for the sequences. Inside, we can right-click and add a new level sequence. I'll call this lineup render because I'll do a turntable render later. This way it's more organized. Double-click and it opens the sequencer with this sequence selected. You can see it on the right side. Press Ctrl-Shift-S to save everything. And we can add the camera by simply dragging it to the left. Automatically, it sets a camera cut, which is just us telling Unreal that we'll select this camera for all these frames. We did this before in the scene study, reducing it to just one frame. Place it roughly at the start and reduce the timeline to a smaller number for easier handling, allowing fine adjustments between frame 0 and frame 1. If you want to make other camera changes, you don't need to go to the outliner. You can make changes directly in the timeline to aperture, focal length, focus, and transform. You can also add keyframes if you're rendering an animation. In the Movie Render Queue window, we need to add a sequence for rendering. Clicking the plus sign shows all sequences in the project. I'll choose the one I just created. You can save this list because closing Unreal will lose your render sequences. But since I'm not doing an animation, I don't save it. I just use a name and location you choose. In settings, it already put the configurations I was using. I'll explain what's happening here one by one. First, we're telling Unreal to render an 8-bit JPEG. We've talked about linear mode, tone mapping, color conversion, and 32 bits, so you know what this means. In other words, it means you don't want to edit this image externally. It's basically exporting from Unreal to put in your portfolio. In rendering, the default option is Unreal Standard Renderer, and we rarely need to change anything here. After that, I added anti-aliasing and chose Override to select None in the lower window. This turns off all anti-aliasing, which is usually useful in animation for different interpolation methods, affecting not just each frame but the quality of image edges. It also interpolates the quality of effects like motion blur. Since motion blur occurs over multiple frames, it needs a way to connect correctly, or it might look broken or appear only on some frames, or it might blur everything. In other words, this anti-aliasing isn't related to shadow quality and light quality. It only controls two things: the quality of the edges and the quality of effects like motion blur. That's why it gives us only two options: the spatial sample and the temporal sample. So, what's my suggestion? Even though theoretically, spatial sample is better for static images, and if there's nothing moving on the screen, even in static images, it's almost unnecessary to use any function of this temporal sample count. But the reality is they multiply. So, in theory, setting 16 and 1 or 1 and 16 is the same thing. In my experience, they still make a difference. And it's a slight difference in shadow projection and even in lighting. We just have to remember that Unreal, when using lumen and not the path tracer, has to approximate everything it shows on the screen. We just have to keep in mind that because lumen isn't a full path tracer, Unreal has to estimate parts of the lighting instead of computing every ray with physical accuracy. It will estimate all the lights and its bounces in the scene. It will even estimate shadow quality and lens effects, such as depth of field. So, in the end, start using the temporal sample count with at least 8, then increase to 16 and at most 32. I don't believe any project rendered like mine here, which is just a character and natural light, will deviate much from this shortcut I'm giving you. Finally, here in Game Override, it's a way to ensure two things, and one of them is the most important of all. It's to ensure that even if your computer can't handle showing in the viewport in real time a cinematic quality, this option will make sure that during the render, which is a separate process from the viewport, it will activate the cinematic options, which is literally this checkbox here. So if possible, for example, if your 3D card is a bit more powerful, if you're unable to use the epic or cinematic options in the viewport scalability, don't worry. During rendering, it will force these options. Basically, the worse these options get, the more it will start turning off lumen reflections, reducing texture resolution, and using less allocated memory for rendering. So, everything will literally get worse. Fortunately, while rendering a frame, it can organize these operations better and do everything at a higher resolution, which is the whole point of rendering something. Another important option for me is that I'm not using the correct game pipeline for this character. It's still using UDAMs, which in Unreal needs to be activated by the virtual texture function. This isn't necessarily a solution for UDMs, but it works for many things, including UDMs. I want the texture streaming option to be disabled because otherwise, Unreal will start considering which bitmap of each texture to use for each small part of the image. In some blocks, it might use a 128 pixel texture and in others a 512 pixel texture and so on. With this option turned off, it will try to use as much memory from your video card as possible and be more faithful to the original resolutions you brought into Unreal. Additionally, not only am I using an incorrect pipeline for rendering, but I'm also rendering in 80K and made 3 copies of the same character. So, I'm essentially loading the textures 3 times and increasing the resolution much more than usual. To ensure I can render this project, I even reduced the resolution of some roughness textures and closed everything on my computer, like the browser and other programs, to save some video card memory. Otherwise, I start seeing artifacts in the small squares that make up the final image. And since this is a very extensive topic, there's much more to explore. This is about optimizing the pipeline in Unreal. I can't explain everything in just a few minutes, but you can join the 3D Masterclass Discord community, and we can figure it out together if needed. Moving on to the output option, this is where we choose the resolution, save location, and which frames to render. The only thing I changed here was the resolution to 768x for 32T. We don't need to adjust the frames since we already did that in the sequencer. With all this done, it's important to save a preset. After any change, come back here and click to save the alterations. Accept it and hope it works. With everything ready, click Render Local. Here we have the final render. Look at this, it's amazing. I think the lights still have the ray trace shadow sample set to 1. So there's a bit of low quality. Still, for a render that took 3 or 4 seconds, it's impressive. In my opinion, small limitations compared to a path tracer are easy to ignore unless we have an offline render side by side. It's hard to spot the differences. Honestly, what matters in the end is the aesthetic quality. If it looks realistic, if the materials seem real, and the design is good, then the idea is conveyed, and that's what counts. With color grading done in Unreal, even with chromatic aberration, look here at his head. Depth of field, all the effects, I don't even see why to take this into Photoshop, unless I wanted to add my signature here, crop this image, or make a thumbnail, something like that. But it's essentially ready. Let's go back to Unreal. We've talked so much about 32 bits. Let's see how to render a 32-bit image. Back in Unreal, let's open the movie render queue options and add the EXR sequence option. Here you can select the JPEG option and press delete, or just turn it off. In the EXR options, choose the DWA or DWA compression, either of the last two, which we've done many times. Another setting we need to add is the color output. Inside color output, I want to disable the tone curve, which essentially disables Unreal's tone mapper. This way, we'll have an EXR file without color corrections, but with a much wider color space than JPG. And that's it. I'll click Accept, press Ctrl-Shift-S to save everything, and render once more. For this second stage, I decided to use Affinity, which recently, if you're watching this video in 2025, was bought by another company. They just released all 3 previous programs into one, and it's free. I'm not going to teach this program now because it's very similar to Photoshop and much easier to use. We only need one function from it, and I find it even more user-friendly than Photoshop. I'll just drag the EXR file here into the viewport, and there you go. It opened in pixel mode and recognized it's in linear mode, showing 32 bits. I have a genuine question about this. Unreal says 16 bits, but it's reading 32 bits here. I'll leave this mystery open about what Unreal is actually doing. Anyway, what I want from this program is to compress the software to the dynamic range. Unlike Photoshop, where we have to add an exposure, then some curve adjustments. Look at this button, a circle with 2 colors. I'll choose the tone compression option. Unfortunately, it's not showing on your screen now, but it's here at the end of this list as the second to last item. Click on this option and wow! The method he chooses is basic, but we can choose Filmic, which should be similar to Blender's. We can choose Log if you want to take it to another editing program. Log usually makes the image look washed out, and although it looks terrible, it's great for color editing. But what I want to choose is Contrast, and that's basically it. Close this window. Here is the before and after in one layer, and who would have thought Affinity would be so good? It's not advisable to do color corrections here, because contrast is all I want to do. The contrast is already good, to be honest. But if we wanted to, it's exactly the same thing. You can add these adjustment layers like curves and adjust all 3 channels at once. For example, add a curve to increase the brightness a bit, and add a second curve to adjust each channel separately. And unlike Photoshop, here in this third icon, it already gives us options to, for example, decrease the exposure, change the shape to more oval, make it really smooth, And once again, the image is finished. Another thing I really like about this, there's already a quick export button here, which seems a bit strange, because I've never seen another program with a similar function. But you just choose all document here, otherwise it will only export the selected layer. Select JPEG best quality and click export in Excel. Open the image once more, and here it is in 8 bits. In Unreal, the process of separating into pieces is a bit different, and we won't cover that. The main reason is not just the difficulty, but you'll see how unnecessary it is. If you designed your entire project considering all its parts, from the sculpture to the texture and lighting, which is the theme of this course, there's no reason to want to select just this object and make any changes to it. If I were regretting my choice at this moment, something is very wrong with my process, because I already had the chance to change the color and shape. The design of all these objects has been refined thousands of times to get to this point. So my suggestion is that you mostly make global color correction adjustments and leave composition for more specific projects or just for your own learning pleasure to understand how things work. In the next video, we'll learn how to render a turntable, because it's also a great way to present your model at a professional level.